Hi everyone. This is a review of stoichiometry that we learned in class um, excuse me, last week. So with stoichiometry, when we first started looking at it, we looked at what happens when you have a mole-to-mole conversion. Then last week we started looking at what happens when instead of getting moles and wanting to get out moles, we're looking at grams. So we've got two example problems I'm going to work through in this video. So the first problem, iron reacts with oxygen to form iron 3 oxide. Okay, before I even look at numbers, I know for stoichiometry to happen, I must have a balanced equation. So to write this, iron is just Fe, reacts with oxygen. Remember, oxygen is one of the diatomics, so it's O2, to form iron 3 oxide. So in iron 3 oxide, remember, iron is going to be 3 plus, oxygen's 2 minus. So we're going to flip the numbers to get Fe2O3. If 3.5 grams of iron react with oxygen, how much iron oxide is formed? So remember, we cannot directly go from grams to grams, right? That conversion doesn't work. So we're going to need to do this in 3 steps, right? Our first step, we convert grams of iron to moles of iron. We use that using the atomic mass of iron from the periodic table. Then we convert moles of iron to moles of iron oxide using the balanced equation. And then moles of iron to grams of iron, moles of iron oxide to grams of iron oxide using molecular mass. Now that we have this equation written here, the first thing we have to ask ourselves, is it balanced? So if I look, I have 2 oxygens and I have 3 oxygens. So in order to fix that, I'm going to write a coefficient of 2 in front of the Fe2O3 to give me 6 oxygens, and 3 in front of the O2 to give me 6 oxygens. Now I have 4 irons on the right and 1 on the left, so I need to put a 4 in front of my iron. So now I've got my balanced reaction with the coefficients. So we're going to do this as a 3-step process, right? Step 1, step 2, step 3. In step 1, we are going from grams of iron to moles of iron. So 3.5 grams of iron converts to moles. So 1 mole of iron, as you can see from the periodic table, here has a mass of 55.85 grams. And if you're struggling with this part, I encourage you to go back and watch the videos from before on mole-gram conversions. So when I do this, I get 0.0627 moles of iron. Great, now I'm on to step 2. So in step 2, I want to convert moles of iron to moles of iron 3 oxide. So I have 0.0627 moles of iron times, so now in this step, I need to convert moles of iron to moles of iron oxide. And for every 4 moles of iron, I am given 2 moles of iron oxide. So multiply by a ratio of 2/4, and I get 0.0313 moles of iron 3 oxide. So great, now I have moles of my product. I just need to convert that final number to grams. So my last step, I take the 0.0313 moles of iron 3 oxide, and I convert that to grams. So I get that from the number on the periodic table, right? So because 1 mole of Fe2O3 has a mass, let's calculate that out, right? So iron has a mass of 55.85. Is that correct? Yes, 55.85 plus 3 times the mass of oxygen at 16. And that's going to give me 159.7 grams of iron 3 oxide. So I multiply that by the 0.0313 moles, and I get my final answer of 4.998, which when we round that up, it's going to be 5.00 grams of Fe2O3. And that is the final answer to the problem. So when the question was asking if 3.5 grams of iron react with oxygen, how much iron 3 oxide is formed? Through these 3 steps, we can see that 5 grams of iron 3 oxide are being formed. All right, let's take that same process and write with this question now. Lead 2 nitrate reacts with sodium chromate to form lead 2 chromate and sodium nitrate. So lead 2 nitrate, right? Lead would then have a 2 plus. Nitrate has a 1 minus, so I'm going to have PbNO3 plus sodium chromate, right? Sodium has a 1 plus charge. Chromate has CrO4 with a 2 minus charge. So I need Na2 CrO4 to balance those charges. And that forms lead 2 chromate, right? So in that case, we're combining these two. So we get PbCrO4 plus sodium nitrate, Na, plus an NO3 minus. This gives me NaNO3. And if I'm balancing this out, I have 1 lead on each side. I have 1 chromate on each side. I have 2 sodiums here and only 1 here, so I'm going to put a 2 in front of the sodium nitrate, which also gives me 2 nitrates to balance that out. So when everything's all said and done, this is our final balanced equation. So the question is then asking, if I have 0.052 grams of lead 2 nitrate, 0.052 grams, how many grams of sodium nitrate are being formed? Fantastic. So again, to map it out, right, I've got to convert this to moles. The first step, then I do a mole conversion, and I go back to grams. So steps 1, 2, and 3. The same process as before. In step 1, 0.052 grams of lead nitrate, and we want to convert that to moles. So 1 mole of lead nitrate has a mass. Let's try to figure that out. So if I go to the periodic table here, I look at lead, which is going to be here, has a mass of 207.2. And then I have 2 nitrates. So nitrate has oxygen and nitrogen. Nitrogen is 14.01, oxygen is 16. So it's going, if I do the math over to the side, 207.2 plus 2 times the mass of nitrate, so 14.01 plus 3 times 16. put that in my calculator, and I'm going to get 331.22 grams. So when I do that math out, 0.052 divided by 331.22, I get 0.000157 moles. It is a pretty small number, and that's okay. Right, we started off with a very small amount of grams, so the fact that our moles are pretty small is completely logical. All right, so that gives us our step 1. Our step 2, now we need to convert moles of our lead nitrate to moles of our sodium nitrate. So I have 0.000157 moles of lead nitrate. And I know there's 1 mole of lead nitrate for every 2 moles of sodium nitrate. Right, again, I'm getting these numbers from the coefficients of the balanced equation. And so I take my number of moles, multiply by 2, and I get 0.000314 moles of sodium nitrate. Excuse me. Excuse me. So my final step, I want to convert this to grams. So I take my 0.000314 moles of sodium nitrate, and I convert back to grams of sodium nitrate. So if I look at the periodic table, sodium has an atomic mass of 22.99. Each nitrogen is 14.01. And oxygen, excuse me, there's 3 of them, and each has a mass of 16. So when I add that up, I get a mass of 85 grams. Sorry, this cold is catching up with me here. So I take that and I multiply by the number of moles, and I get a final mass of 0.0267 grams of sodium nitrate. Again, that number is small, but we started off with a very small number to begin with. We only started off with 0.052. Hope this helps. Let me know what questions you have.